I'm John Grimsmo, and this is Knifemaking Tuesday, week 28. So I'm here at Intercut Waterjet, just about to pick up a whole bunch of parts. These are all my paramilitary handles. These look amazing, man. And there's lots of them. That's what I like to see.
Mm-hmm. So you getting? Are you ready for the show then?
No.
You got a lot of
we got 2 weeks, and we'll do what we can. Right?
A lot more than a two-week job to get all this stuff cleaned.
As long as I get some of them done. Yeah. These don't matter so much for the show, but these do.
Oh yeah.
So there's the scrap piece there.
Yeah, these nested really nicely.
Wow.
You don't have much waste at all.
This is their flow water jet. I have these same ones at home.
Oh, yeah.
Nice. So now that we're home with these big sheets of water jet, Erik is popping them all out. So they're just tabbed on one side. So it makes them very easy to pop out.
Yeah. The paramilitaries were a little bit harder.
Yeah. So this here's a 3-pack of paramilitaries. All tabbed together because that's how they fit on my fixture. And here's a 2-pack of paramilitaries. Tupac. Yeah. Too much stuff. Too much junk on the table. A brand new table, and we're like, yeah, we're gonna keep it empty, you know, so we can always use it for stuff.
Anodizing.
Yeah, for anodizing. These look pretty excellent, I do say. Notice the lock bar slot, but I left the lock face uncut so that I can machine it myself. And everything is oversized, so I'll be machining all the edges. Nice tabs on either side for bolting to my fixture. And all the holes are spotted. And right here, that didn't go deep enough at all. Not cut right here and right there. Weird. I wonder how flat it is against the bottom. Like if you can get a shim in there or not. So we're trying to face this fixture down, and as you can see, it wasn't flat to begin with. I'm trying to face down 25 thousandths of an inch, and I thought that would get rid of everything, but so that fixture is going to be for Norseman blades, and this fixture here is going to be for Norseman handles. If you haven't seen my other video, as an example, this is the fixture for paramilitary handles. So same exact outside, same bolt holes and everything, just all the fun stuff in the middle is different. So we've got a real family operation here. Brother / Uncle Erik, Dad, Clara. She's playing a puzzle. A titanium puzzle. Erik figured out what the problem is with the facing pass here. The bolts that we're using are too long. And I think the head pocket got pocketed deeper than it's supposed to be, so the bolts are actually sinking down a lot lower than they need to. really bottoming out on the bottom basically. So Erik's just shortening them right now. So he's manually machining with the CNC lathe, keyboard in hand, watching the numbers. So I thought this might be an interesting little comparison. On my waterjet parts here, I've got a stack of a basically waterjet cut Norseman knife. Got the clip and everything. So this is full raw material, not including the screws or anything, but I see 6.9 ounces. Taking it down to a machined version, 3.9 ounces. So almost half the weight, not quite. But you're taking a full 3 ounces off the weight. Oh, and the clip. Almost forgot. So 4.1 ounces with a clip. From 6.9 to 4.1, that's a lot of material gone. I like it. Just for curiosity's sake, a paramilitary 2 with G10 handles. It's about 3.8 ounces. And mine's 4.1, so hardly heavier than a production Spyderco with a flat ground blade. I think they're about the same size. Yeah, actually my Norseman's a half an inch bigger. Quarter inch. Anyway, it looks a lot bigger, but it's super duper lightweight, yo. Moving on. Hey guys, so I just wanted to go over some of the CAD work that goes into producing these blades. So as we can see here, I've got my large fixture that we made recently, and these are all my waterjet blanks. And you can see the fixture has all these various bolt holes. There's some here too, so that you can bolt everything down, as well as some extra bolts so that you can flip the part over and clamp it. Here are some clamps that I've got. These are little steel clamps that I made. Very, very handy, useful things. While making them, there's various different clamping solutions that I'm going to use for each operation. The first thing I'm going to do is just bolt it down by the 3 tabs, and that'll let me drill and ream the pivot hole. That'll let me machine the internal stop pin area, drill a jimping, drill and pocket the thumb stud hole. What else? I've got a notepad with my list of operations, basically. So like previously, I will be actually machining the edge bevel of the blade. See, it's slight hollow ground. So I'm going to be machining that. So I need the blade to be held down very well, very flat, and hopefully the tabs don't get in the way. So while it's fixtured in on this side, I'll be able to go in here and machine like that, machine all the metal away, and then I have to figure out how to cut the tabs off while holding the blade down otherwise. So that's where this top clamp comes into play, is I can do that, and it gets complicated. I forget how it works sometimes, but... And then another thing is, after heat treat, I've got 2 clamps here that the blade goes back on and gets hard milled. And I found out in week, I don't know, 14 or 16 or something like that, that to machine this bearing pocket, remember it's rolling on ball bearings. This bearing and the other bearing need to be absolutely dead flat to each other, and hopefully have a nice surface finish so that the bearings roll really smoothly. And the only way I could find out to machine those dead flat to each other is to clamp it evenly from either side. So you clamp it from both sides like this, and it's just flat. And then you can flip the blade over and do it again, and it's totally flat. Which reminds me, I need to put this hole over here, where my moose is, and this one as well over here, so that when I flip the blade left to right, you can see there's two blades here. One's flipped one way and the other flipped the other way. Another thing is a little dowel pin that's going to go right here. You can see the top edge of the blade can rest up against that, so it's a stop, and it'll let me reposition the blade every time once I machine this edge. For waterjet, I'll show you. You can see the waterjet edge is quite a bit thicker, 20 thousandths thicker. So once I machine that away, then the actual edge right there will be able to rest up against a dowel pin. And then just in case, I will drill dowel pins here and here for the stop pin area, in case I want to put dowel pins in there for positioning. So we'll see. But yeah, my step right now is to machine the basic parts of the plate are machined. I have to drill all these holes and ream various ones, and make pockets like this, and press in hex nuts so that I can thread into it. But that's this morning's project. It's Wednesday right now. More work to do. And real quick, also doing the same thing for handles. You can see I got the handles here, but I haven't put them on the fixture yet. But here's the handles with the outline of where the water jet is. And so I'll have to figure out a way to fixture that and machine that. And same thing here with the bearing pockets. They have to be very flat, and the stop pin hole, which actually belongs over here, yeah, has to be like that. And this little section in the middle will be for inlays for some handles. So I just wanted to code that, so that for some handles I can make a pocket here and then also make an inlay of that same shape and glue them together. And I think it would be sweet to have this diamond pattern machined into both the inlay and the handle. Alright, real quick, let's wrap this week up. It's Thursday. I know I'm supposed to have posted this 2 days ago, but finally got my blades fixture done. A few problems due to idiotic mistakes on both Erik's part and my part. We are each at fault there. If you notice a sea of holes here, a lot of them are not being used, like this one and this one and this one. First mistake was Erik machined it first from this side, and the code says to flip it this way, but he accidentally flipped it this way, so everything was off center. And even worse was the coordinate system I used, the 0 location was in the wrong spot, so the holes from this side did not line up when you flipped it and drilled it from the other side. So anyway, that's boring details, but I fixed it. So we're just left with a lot of extra pockets that don't matter. If you'll notice real close, there's pressed in some metric M6 nuts and some small M4 ones here as well. Those are going to help to bolt everything down. Up until recently, I was all excited to use these binding posts that would get pressed in from the back of the surface, stick up a little bit so you have a locating pin and a screw hole. But it turns out that's kind of an epic fail because, let me show you. For example, here's a blade. If that goes in here, wherever it goes, I don't know. I guess it goes like that. And there's a binding post sticking up that this locates onto. Let's say here, binding post sticks up, so it's sticking above the surface. You know, if it was like that, to cut the tab off, you would end up chopping the binding post right off anyway. So it would become useless the next time because it would be below the surface. It'd be gone. So they'd be kind of only a one-time use unless you had two different fixtures, which is what I ended up doing with the paramilitary handles. One has binding posts sticking up and the other just has screw holes like this one does. But anyway, blah blah blah. This one I'm still going to use the binding posts, but only as an alignment pin. So once I drill these out with the letter D drill, they will align into these holes and the binding post lines into that hole. Any of these bigger holes. So I can align it using 2 or 3 pins and then hold it, take it out, and then screw in there. This fixture I believe will let me do 12 blades at once. Something like 2, 3, 4, something like that. And then it gets flipped on its own axis and machined on the other side. Now, unfortunately for you viewers at home, machining these is the very next thing I'm going to do in the next 10 minutes. However, this video is over. So you will have to wait until next week's video. I know I'm so mean. But finally some action. So next Tuesday-ish I should be posting blades, hopefully handles as well, and lots of progress. Anyway guys, thank you very much for watching. Knife Making Tuesday has come to a close this week. For you anyway, for me I'm still working. And 2 weeks till Blade Show. Oh my god. Take care guys, thanks, bye. Alright, that would be mean. I will show you making blades. Because I just did it. Check this out. Turning waterjet Norseman blades into actual Norseman blades. A lot of steps in the process of doing this. And first thing we got to do is drill out these waterjet holes. I had them drill it undersized so that they fit these pins. And then so we got to drill it out so that they fit the pins. So I spent all day figuring out the tools required and the
Stop
code.
talking, we got work to do.
Okay, fine. So as Eric said, we got work to do. In the drill check, I have a letter D drill bit, and time to punch out the holes so that they fit onto our fixture. So Eric's controlling the machine using the jog pendant. He's going to bring it down. I'm going to hold the blade. Got this bolt in here so it's a work stop so it doesn't start helicoptering. Hopefully it'll work. Maybe I should put my glasses on.
Oh, for sure.
Practice. Up. Do best. That should be good. Keep going. Let's see. RPM too fast.
Too fast.
Yeah, see how it's blue? Yeah, it's very blue. Very blue. Means it's getting hot. And it is. So we're going to turn the RPM down. Those 1200 more. Hot. Fast. Whew. Of course I didn't realize it's going to shoot extremely hot chips all over the place.
Molten hot magma?
Yeah. Liquid hot magma.
That's what it is.
And it's leaving a crappy finish. These all have to be deburred. On second thought, I should have had the waterjet guys try to match the hole exact to what I need it to be. That might have been a good idea.
Seems like they got close.
Because now we have a buttload of holes to do this too. So in hindsight, having the waterjet place undersize these holes, I think I went 20 thousandths wall thickness undersized. And then having to open it up was kind of a huge pain in the butt. But finally did it, and then we had to chamfer both sides so that the pin fits finally. Next time we'll probably have them do it. Try to get the waterjet to be as close as possible. Maybe even like 2 or 3 thou undersize so that it's really easy to drill through. 20 is too much. Next up, put the fixture on, start bolting it down, move on. Here's my blades palette. Right on. Like that. It's bolted down using 4 cap screws, low head cap screws. To get the blade lined up, we're going to use these binding posts, which are basically, in this scenario, like dowel pins that you can pull out. That's pretty tight.
Like a tiger?
Tight like a tiger. A little bit more play than I was hoping for with all that effort, but... So now I go over and I open the right piece of code. I gotta find it. There it is. At the top of the code, I like to list all the tools that I'm going to be using so that it keeps it nice and clear, and so that I know the first tool that I require, which is tool 29. And what that guy's going to do is drill out the pivot hole and make it a little bit bigger. Sounds a little bit better than doing it by hand. Holy cow. Okay, now what? Tool 11. Bam, hit it. That's going to ream that hole to an undersized number. And then after heat treat, I'm going to ream it out to full size. Nice. So after heat treat, full size using a carbide end mill, or reamer. What's next?
Tool 18.
Tool 18. Hit it.
Hey guys, Eric here. John went in to put Claire to sleep, so I'm just running the rest of the code. And yeah, so here we are with another end mill doing who knows what. We're doing the profile pass, just taking away that little bit that the waterjet guys left on for us. And next we're moving to an 1/8 inch end mill, if you can see that there. So right now we're doing the facing of the edge with, I can't pronounce the word, toroid bit. It's one of the ones with the 3 little inserts on the sides. And I have to say it looks pretty cool from here. Nice. See, on the last blades we had a lot of problems with, you know, chatter, or maybe the end mill was getting dull, so the blades kind of looked like crap. But this one so far looks quite clean and very even. Now I think on this next pass it's going to chop the bolt a little bit on the side, so we might see some noise. Alright, so take you in for a closer look here. Oh, it's looking pretty good. So this is the first, I guess you could say, soft milling. After this, once we get the blade all milled and everything, we're going to get it heat treated and then do another pass when it's all hardened, so we'll hard mill it. And hopefully that'll look really sweet and just turn out extremely nice. So we have now flipped the blade over, and we're going to do basically the same thing with the other side. And that's all I have to say about that. And actually, that was not all I had to say about that. What I'm going to do now is install this little finger clamp on the back side of the blade here. And I guess just to hold it down and keep it a little bit more rigid for the second pass of machining. All good so far?
How'd it go?
It looked awesome, the other side. Oh my god! Yay! I zoomed in for this one.
Okay, are we on the right track, or are we on the right freaking track?
We're on.
That even sounds good. Have I mentioned how much I love this machine? So if you've been following my old videos, where I've done this in the past, I've probably got 3 videos where I've machined blades in the past, and I do different step down distances to get different spacing between the lines. This is 2/1000ths of an inch. I've done 5/1000ths, 2,000, 1,000, and once we get this out, we'll look closely at it, but I think 2 is a good number. Especially with this particular end mill, this toroidal cutter. Also called a button cutter. Now, I don't know if we've mentioned this yet or not, but obviously the fixture is big enough to make, I think, 12 blades at a time. Obviously we're just doing 1 right now to test out the code, to debug it. There's already been a few little mistakes. I don't know if you mentioned the tool difference.
No.
I think I told the program said ask for tool 24, but it's actually tool 23. That could have ruined a lot of stuff.
23 and 22.
That's what I said. See what I know? Nothing. But every change we need to make, we write it down, change it for next time. Check it out. First blade on the Tormach. Near perfection. Surface finish of that button cutter is epic. So a few little tweaks that we need to do for the next run, which will be right now. And after that, so we'll make one more, and then after that we'll make a whole pallet full. And I'm so excited. This is awesome. Yeah, a few minor things that are wrong, but I can still use this blade. It's still totally usable. Yeah. So that's that. Wrapping up Knife Making Week 28. Thanks for watching, guys.